Welcome to the Slop Farm. Enjoy the video.
You start by confirming the motor type and limits. That matters because control methods differ. Once you verify the nameplate RPM and supply specs, you can pick a safe control method. Next, isolate power and connect a variable supply or the appropriate controller. Make sure grounds match. You should also attach a tachometer to monitor actual RPM. These are the first actionable steps. Verify ratings, secure wiring, and prepare measurement so you can change speed without damaging the motor. Once the hardware is ready, you implement the control approach suited to the motor. For DC, apply PWM at an appropriate frequency or adjust the supply voltage. You reduce voltage to lower RPM and increase it to raise RPM. For AC motors, install a VFD and modify frequency and voltage ramp parameters because RPM tracks line frequency. For brushless motors, program the ESC or use a controller with feedback. Make sure PID gains suit the load. Monitor tachometer and current while you adjust to avoid overload. You finish by slowly ramping to the target RPM while watching current and motor temperature. Abrupt changes stress bearings and windings. Once stable, log the settings and, if using closed-loop control, fine-tune PID gains or VFD acceleration/deceleration to eliminate hunt. If RPM won't hold, check wiring, grounding, sensor calibration, and controller configuration. A key troubleshooting tip: if speed fluctuates under load, inspect the feedback sensor and verify your controller's integration.
Thanks for watching. Consider subscribing if we helped you today.